Any questions for Franklin? Session. Okay, well, if not, we can move on to the next step, which is the hands-on lab on VerifAI. Yeah. Okay, thank you, Franklin.
All right, so I and Eric and Kay work together to create a hands-on session briefly on VerifAI. Just share you the link. Here is a link, but I guess so using the meta drive or Newtonian simulator, running Scenic Newtonian simulation like we did yesterday. And quickly, let's try out very simple. Okay, so here is actually I'm sorry. So here is the URL. Please go there, and then there's a Google Doc that contains all the instructions as to what to try and what to download. That's
Please let us know as you guys have been focused on VerifAI. Things involved.
Yeah, I think we'll just, I guess we just, as a general discussion, we can have. Well, I just want to make the lead like, in which is the end of the
should be
Yeah,
or VerifAI hands-on session.
it's supposed to end at 2:15, so we will be past those. Well, we can see how it goes.
You don't have to extend it.
Well, let's see, if people are still working on it, we'll probably something.
Oh yeah.
I'm just trying to get this.
Oh, he's see. Yeah. Says.
Of course, so for this, you will probably have to also install meta drive and run this is an absolute
No, I'm not doing anything locally. Or in a cloud.
Whatever college, yeah, that's.
Hang on.
Yeah. Yeah. So after it's something, launch was installed, right? So I'm not waiting,
Oh, this is some very.
no, sorry, it was,
Okay.
so I'll go over it, but it's two things, it's something horrible stuff. And then you get, both.
And by this
Small, I said,
Yes, I guess, okay.
Yeah.
It's about, what do you know?
There's a bar on the blue.
No, good. Very.
Oh, it's not going in, it's not good. It's screen share and Google Doc,
The tinyurl.com/verify-xml.
Yeah. That's
That's the doc.
yeah, that's the, yeah, without instructions. tinyurl.com slash verify dash, exactly.
This question is really very.
Yeah.
Yeah,
Yeah,
I
that-
just, am I seeing it? This what you done, a one folder, not like a folder inside.
No, everything, the entire folder.
Also, so I see.
Yeah.
It's called verified AI.
Yeah.
Maybe the brand is in. So something like that. So, I'm not sure whether you can also,
Okay.
verified AI example.
Yep, so Scenic is verified, so, yep, and then you just have to download the tech code. Anywhere. Anywhere's fine. Alright, sorry, and then I learned this. Yeah. Oh, that's installation. I don't know. Did you run the Python? Oh, you did. So, you don't want to. I don't know. I really closely met with the advisors. Oh, yeah, that's.
Person who has to be.
What was the job?
But it.
Yeah, what do you make sense? You just don't see it there. Oh, it's not. If we can talk same aspect.
It's single version, so.
Yeah, so then it starts to. So bad, I would see. So it's probably very good.
Yeah.
Just get the thoughts. Okay.
Okay, so when. I'm gonna close it. See, so I saw them there. Outside of the defense.
Oh, see also.
I just. I live here in this stadium. This is all. the overall value of the back of our, yeah, that's super, that's really important. Version of our customer, inside, you'll see that some, very pretty similar to. The very top. Then, it's another over and on.
Is anyone having trouble running this?
There's some new line.
It's really just like the line, it's mostly.
Cars park, this crash house.
Oh, of course.
Obviously, so. It's not sure what. I never used to be.
Yeah.
Using the same version too.
Okay, so I think like pretty much all of you were able to run it. So, except for Lawrence.
Something's supposed
So,
First time, we're starting from sitting better by.
Always explain why.
Very nice. Still trying to. Speed running just.
weird.
They always be what? I don't know why. But then. Oh, that's right. How about, yeah, practice and try using the overhead practice. Moving right, then they will keep on. One, and then, just do the edit one, so copy, just say from. That was nice. No, you don't build it, I think it's all actually. So,
Or this guy. Over. 3.10 or 11.
sorry, for this.
So the progress bar two issue, so. You should be, that's just apparently, progress bar is max, progress bar two to max, initial value.
Yeah. There's something around something pilot. Yeah, we will and then.
Yeah.
We shall start.
But look at it, both versions too.
And then, do
It's like,
I don't know, install, so, install.
if you try to install or.
Actually space. Let's see, this was. Yeah, regular pattern is one for
Yeah, we was on our list too.
That's really cool, yeah, it does, it's, pipe down.
Tourists are cheap.
What I do is serious. Yeah, this thing's environment, right? Cool.
There's really video style, there's. Like, this is an actual called other spots, these other ones too now. Yeah, I'm just wondering how this is. Oh, I.
Yep. And again, it's also really.
Just regular paper back then.
Right, it's like override.
Some to. Yeah. Yeah, similar is on very straightforward. Yeah, yeah, verify, yeah, similar to having some verify actually. They have similar to And I'm not part of the four of the section. We say we want to do the same thing here. Alright. Oh. That is the same kind of business that kid where it's also one version of the course. I haven't done that yet. Oh, you haven't installed it. Yeah, so now I have to install it. Oh, so that's fine. So what is it? As long as, yeah, just, should have. Okay, so it's a verify for now. Yeah, it's right, yeah, because, as long as you install the Scenic, it's fine. But because what happens is that you don't have a Scenic, you install verify, then install the Scenic. But that's slightly outdated. The Scenic verify is not slightly outdated. So now I can install Scenic. Okay, so I could just do like Scenic for Burping. Yeah, so probably, if you yep, see that, that one. Yep, and, and then, see. See, and then, Python actually install that sheet, so new, because what happens is the high version hasn't used to be it, so it hasn't used to be more stuff supporting manager, full manager thing. Yeah, so yeah, right now, right now this is all download from the show. This one and the down the back one. Oh, yeah. Yeah, no, but I did. Yes, we'll do it. Then 1.5 has a default, but this time. But yeah, I got it. Yeah, and then it's but okay, first time running meta drive also gonna take that. I think that very first time running meta drive, you always take like 7 it's not bad. It's not bad. Yeah, it will run like 20 years. Yeah, it runs for yes, it runs for 20 years. And what happens is that any work is overall it's gonna well happens is that you know somewhere. There's a bad part for our and then complete the bad part is full in. We're going to see it's called parents. It's actually very fun. Make it parameters our part. And goals is that's how you do goals and everything. Time is only end time. Essentially, as you move on in your simulation, you'll see verify the some scenarios like more abstract. It's so very fun. More frequently, you have those calls that are actually yeah. Is this thing actually running?
Go ahead and point the rest.
I'll try to look at it. I just said, oh, yes.
Oh, they're, happening again, no problem.
Okay. Yeah, it's just understand confidence part. It's not just confidence part. That's why you want to part. Yeah, man.
Weird habit.
And then do. Turning zero equals something. Actually, let's say it's time.
Clarification?
This is essentially so I'm thinking how to do it. So if I just
Actually, other parts of it, I'll call this.
I got it. All right, got it. Okay. Period, not.
Oh, okay. Good.
Yeah, the limitless statute.
That's two parts.
Yeah. So the problem is not
So what happens in programs that is this?
Oh, are you doing it?
Yeah.
Yeah, I agree. That's okay, because it's the now it's also like this. Okay. No.
Yeah.
Okay, everyone can run it at this point, so let me go over briefly what you just ran, the logic behind it. So let me start with the Scenic program and then move on to the VerifAI. So, within the Scenic program, it's basically modeling the. Okay. So one more. Okay. Eric. Oops. All right, so there's an echo. I thought I moved. Okay, so let me just quickly go over the logic behind what you just ran. So in the Scenic, let me start with the Scenic program and then move on to the VerifAI. So in the Scenic program, it's modeling the badly parked car case, which you have seen yesterday. So I'll skip the modeling part and then I'll focus your attention to the last part of the Scenic program. So line 48 to 56. So in 48, so I mean, actually, if you look at line 55, it says there's a record statement. So, and then you're recording the true distance between Ego and a parked car under a variable named dist, right? And what is the true dist doing? It's basically taking in two car, and then within that car, it has an attribute called bounding polygon. And then in line 52, it's calling the distance between the two. What does distance is, so first of all, what is a bounding polygon? It's basically outputting the outer vertices of that polygon. So if it's a rectangle, then there are 4 vertices, right? So that's what BP1 and BP2 are representing. And then if you call this distance function on top of that, it's basically finding the 2 closest vertices between these 2 polygons, right? And basically that's how you detect how close the two cars were, right? So that's what we're doing. And then we're saving those the distance, that's why we're calling it true distance. And then we're saving the distance between these two cars at every time step. So right now Scenic is running by default at 10 Hertz. So every 0.1 second under the variable name dist. Now, if you go to the verify Python script, here now, this is a templatized specification. So you can just use the same template, and this simulation will always contain information that is recorded. So here in the Scenic program, you save the true distance under the variable name dist in line 25. So this is a Python script, falsify distance.py, line 25. There you're accessing from the simulation result the true distance that was recorded at every time step. And then here we're returning. So what is the metric? We're finding the minimum of this time series true distance data, right? And that minimum is telling you the closest distance that two cars encountered throughout the simulation, right? And here, and then in the lines below, from 31 and below, you're specifying again the number of simulations to run, and whether you want to save the error table and the save table, which should have printed out in your terminals. So the error table is outputting all the environments that are sampled that resulted in the failure of this specification. Save table, the opposite. And so I set it to true for both of them here, or Kai set it to true. So that's why both of them are printing out. And then if you want to, right below in line 37 and 38, if you want to also further save that as a CSV file, you can do that too. You just have to uncomment those line 37 and 38. And then here we're specifying each simulation step as 100. So again, Scenic is by default running at 10 Hertz. So that will be equivalent to 10 seconds at max. Okay. And then once you run it, you'll see in your printout, the error table and the save table. For the error table, you'll see the error table and the save table, you'll see the row value printing out. That row is basically the result of what's computed in line 26, right? So for the error table, it will be all 0, because by default, Scenic uses 0 as to determine that it's a failure, unless specified otherwise. So that's why in the error table, all the row values are 0. And then in the save table, you will see values greater than 0. Therefore, it's safe. Yeah. Any questions? Yeah.
The example, so always it's greater than 0. Do you have? I've never worked with VerifAI with the general question. Do you have a code base that I can just enter whatever specification I have in simple logic, and then got the results from that?
Yeah, so this is again basically a template, right? And within here, you can access the data that you
But the question is about, like, here you wrote this minimization yourself.
Yeah.
But it would be nice if you could write globally, eventually, etc.
Exactly.
And VerifAI does allow that.
Mhm.
You just didn't show it in this demo.
Yep.
So do you want to maybe go to
We
an
have a
example?
very temporal logic library
Oh, okay.
that you could define the temporal logic.
Just in the examples folder, you can see some like that.
in the documentation, you mean? Or
In the VerifAI repository, in the examples folder. Just pull up one of those examples. I think all of them use.
here you mean
In the repository.
in the repository itself, okay. Oops.
Oh, you don't have it?
examples, yeah.
You can pick.
Scenic probably.
So
Yeah,
there at the top, that, yes. you can zoom in there.
I see, yeah, I see one.
So there, the safe part is uninterpreted. That's like an atomic proposition, which you have to provide, and the code below does that. But you can put in globally eventually, and you can put time limits like in STL also, or in metric temporal. It's metric temporal logic, yeah. So you can do that. The hard part is doing what Eddie showed of defining essentially the signals that you interpret this over, and you need some custom code for that. But as shown in the example, you can try to basically offload the hard part of computing the signals to Scenic, the record state, and then you can just put those together into a specification, a little block of code like this. And one thing we're planning to add in the new version of VerifAI that Eddie mentioned is the ability to refer to these records automatically. So if you just say, like in your Scenic program, record blah as safe, then you could just write globally safe here and not have to have this boilerplate. So that will hopefully be in soon.
Yep.
One of the things that I see that we have now the terminal, so it's something that so it is benefit. So it is different over the of the offer.
Yeah, so the question is, what's in the error table?
What's in the error table?
Explain that.
Yeah. I think that the printout is not, it's hard to parse. If you uncomment line 37 and 38 in your verify script and then run it, it would also save the CSV file. And then if you open up the CSV file, you can actually see more in detail what are the names of each semantic.
What is the value of this? I think the probability is complex, right?
Yeah,
It's all
that's right.
all random values. So actually, it's not necessarily all properties of the object, because the ones which are fixed are not included because they didn't change over the course of the different simulations you ran. But all parameters which changed, like were random or not necessarily random, but you sampled values for them using one of the methods in Verify. All of those become a column in the table.
So in this example, the color attributes are two columns. Then the third column is the other one. I forget the name of it.
Yes, like if you had the random position for a car, you would have X, Y, potentially Z columns. If you had several objects, you'd have those for each of them. Time of day, if you vary that, there would be a column for that. The name at the top of there's a header which should explain the meaning of each of the columns. And then so all of the columns are like that, except the first one, which is just an index, I think, of the simulation number. And the last one is the row value.
Yes.
One other thing in the new version of Verify that we hope to add is a facility for you to add custom columns to the table, because often you may want to save extra information, which was not one of the parameters that was sampled, but some other outcome of the simulation, like these records, right? Right now, Scenic can collect those with this record statement, but Verify doesn't have a way to automatically put those in the table for you. But we're hoping to add that so that if there is extra information you want to save, like what was the minimum distance between these two cars or something, you could add that as an extra column. But right now, the columns exactly, except for the row and index, it's exactly the parameters of the scenario that was there.
Also, I should mention the table that is printed out on the command line on the shell is only part of it. It's still dot. Yeah. So if you see a CSV file, when you were saying it has all of it.
Yeah, Maria.
With the, let's say that we have a long formula that we want to debug if we have a counterexample. Can we have, do you have that feature that maybe can we analyze this robustness of such formula as well as the debugging feature? Like saying you have 5 subformulas in conjunction. Oh, this is the one you are violated, so maybe you you want to try that first. Do you have that feature, or do you plan to something like that?
I don't think we have that. Yeah, yeah.
Actually, so
But it's a good idea.
no, but this might lead to the multi-objective falsification that Tyson presented. That will also be integrated into the new release. And so you can of course specify, 5 properties all at the same level of priority, which would be this. And then it will tell you which one was running.
Oh,
So that
we
we
don't have that in.
With the questions of the coding.
No, we didn't.
Yeah. I have two questions about-
We- yeah, we-
This is verifying.
We
So
want-
you want to verify, but do you have to have properties that you get the one rules, or did you? I guess like for the reward, where you pick the top or the worst.
Yeah,
that-
good question.
hang on.
The question is, can you specify a reward or cost function?
Rather than the property, or I think I'm also thinking about in case where you have a policy that's like really bad, so you don't want to train on all bad places.
Yeah.
You want to train on.
So the short answer is yes. You can, notion of the specification here is not just a Boolean notion. In fact, the example that Eddie has.
But it has a value, but what if you don't know like the values that you're expecting to get, you don't really know the range of words.
That's what came to,
Okay.
I mean, you don't know if they're.
You don't know the priority, yeah, so you would set like a range.
What do you think? Is that
Yeah, like by.
Oh,
Good,
good.
Regarding-
any value of the quote specification function, which is 0 or less, counts as an error. And anything positive counts as safe. You can actually configure that in the falsifier. But yeah, that's all it is. So if you don't know what the range is ahead of time, right? You would just set the threshold to 0, but save both tables, or you could set the threshold to infinity, and then everything will go in the error table. So,
Okay, and then I guess you could do some post processing if you want like fast.
Yeah, right, yeah, that's a, that, well, so you will iteratively. If you want to iteratively search for examples where the value falls below a threshold. When you don't know the threshold entirely, but you might learn the threshold as you go, I think it's a script for our emotions. That's a really interesting.
They talk about what's going on in the Scenic program. And
Yeah.
how, yeah. All right. So Eddie just gave a very good coverage in terms of what happens inside this. Oh, it's a bit zoomed in. What happens inside this this verify file. This wait, it's not responding to my fingers.
Yeah. This is your computer.
How do you zoom out a little? Okay, yeah. So
I'll make sure it's down.
yeah, so in this file, we show how to actually, run the falsifier, how to give the specification, and how to actually falsify the specification. Now, let's actually go to the Scenic file because there's something that's going on inside the Scenic file too, other than just the description of the scenario. For example, because in order to take advantage of verify, you have to add a little bit to your regular Scenic file. So the main thing, first of all, you want to specify what sampler verify is using. The standard sampler, so it is specified by this param right here. It's called verify sampler.
Reference the line number. Because we can see.
Oh, I see.
Yeah.
On line 12. It is, so if you focus on line 12, this is the parameter called verify sampler that specify what kind of sampler would you like verify to use. Different samplers have different properties in terms of trying to discover counterexample. This is your this is Bayesian optimization, which is essentially like an optimization algorithm used for black box functions. Don't have to worry too much about the detail, but namely there are two categories of samplers. One is the active samplers, and the other is the passive samplers. In the active samplers, what happens is that in general, verify will analyze the history of the simulation, how your agent performed throughout the simulation that has occurred. And based on that history, it will perform some analysis. And then it will compute a feedback to these samplers. And based on this feedback, these samplers will figure out which areas in the distribution are more likely to cause an error in your system. So, and then, different samplers determine this in different ways. And then they each have their own sort of ways of computing. Oh, okay.
Error. It's actually using Alton sampling.
Oh, really?
Because they had the wrong name.
Oh, I see. Okay. Yeah, so it will, they have different ways of determining which area in distribution was most likely to cause the error. So there's the those are the active samplers. There's also the passive samplers, which includes things like simulated, annealing, Halton, and also just your regular uniform samplers. These samplers each have their own way sort of to ensure some kind of coverage over the entire distribution space that you have specified. For example, for the Halton sampler, it's based on the Halton sequence, where it sort of just it tries to it's deterministic. It deterministically covers your entire distribution. If you think about a real line, that Halton would just sample first coarsely, points on the real line that covers the entire range, and then it will sort of like start stepping in sort of finer intervals, such that as time goes on, it starts to cover more and more, a larger and larger portion of the range you have specified. And in the case where you have multiple distribution, it's sort of just like a higher dimensional generalization of that. So this is the specification of the verified sampler type. Now, if you go down here, the other thing you have to change from your regular Scenic program is from the specification of your distribution. So, for example, where is it? Oh, it's up here. So, for example, in your regular, perhaps you guys recall it from yesterday, so there is another version of this badly parked car pulling in .scenic inside your Scenic repo. So what is different about this one is that we have, rather than specifying distribution, so if you look at line 17, right, in your regular Scenic program, you want to specify distribution using like a regular range, like without the verify. But in here, we have added this verify prefix before the range. This essentially tells verify that these are the verify ranges are the features, are the parameters that verify keeps track of. They analyze these, and the active samplings are also performed on these verify ranges. If you have an additional parameter that is just range, say I'll just call it P, range equals range. You have some kind of maybe 0 and 1. Verify will not analyze this range. Verify doesn't care about this range. Verify doesn't keep track of it. This range will be your regular uniform sampling, and it becomes essentially part of some kind of randomness inside the environment. Whereas verify range, so the verify ranges are what verify keeps track of and analyzes and actively samples. And these verify ranges are really the semantic feature space that verify searches over. It will consider which of these verify ranges are most responsible for changing the behavior and which regions in those distributions are most likely to cause errors. So if you want to use verify, basically you have first of all, you want to specify a sampler. If you don't specify a sampler, it defaults to Halton sampling. It's Halton sampling, right? Not Scenic. If you don't specify a sampler, it defaults to Halton sampling. And if you specify a sampler, you can use whatever sampler you want. And the second step is to make sure all of your ranges are, all the distribution you want verify to analyze and keep track of are verify ranges. Even though it is called range, it is in general, it won't be a continuous uniform distribution because of the underlying verify sampler behavior. So one more thing is that in terms of actual coding and using it, any range, any distribution you would like verify to keep track of has to be declared with this param syntax. You have to say param, you have to name your variable and say this is a verify range. And when you're actually trying to plug these ranges into your Scenic expression, you want to do something like this: global parameters dot trigger distance. Oh yeah, this is on line 23, by the way. So if you look at line 23, you have global parameters dot trigger distance. Trigger distance, if you look back to line 17, is one of the verify ranges that we have declared. So in general, to sum it up again, if you want to have a range that verify keeps track of, you declare it as a param, and then during the inner Scenic body, you reference it as an attribute of this global parameters object.
To explain that a bit more, it's not necessary to use the parent statement here. It's just that because of the way verify works, you can't create verify ranges inside behaviors. They have to be declared at the top level because verify, the sampler, in fact, all of the samplers in verify need to know what the whole space of parameters to be sampled from is statically at the beginning. So you can't create new parameters at runtime during a behavior. So that's why they've been lifted out here to the top level and then referred to inside the behaviors. That's also something we're hoping to relax in verify, but at least at the moment, everything needs to be sampled at the top level and then it can be referred to inside behaviors later.
Thank you, Brian. Any questions?
Maybe I'll just mention a couple of the things about this. If you want to stop sharing.
Okay.
Um, oops. Okay. So this is described in the documentation, but it's a little bit hard to find. So this comes under in the Scenic documentation, I mean, this comes under the rubric of external parameters. So Scenic, as we talked about all yesterday, mainly you define distributions over random values. But Scenic has the ability to call external code to sample values for parameters. That's what's being used when you use VerifAI to control parameters within Scenic programs. So there's this page on external parameters with technical details of how to do this. Like if you want to hook in your own custom sampling tool, we won't get into that here. But there's a section on using samplers from VerifAI with the kind of syntax that we just talked about, right? So VerifAI range, as Kai said, says this is a parameter whose range is 5 to 15, so it has to be within those bounds, but we're not putting a distribution on it. We're allowing VerifAI to choose in some non-deterministic way a value within that range. And as Kai mentioned, we use the Halton sampler by default, but you can change which kind of sampler you want by setting this global parameter. So there's more stuff here I'll just mention. So for example, you don't have to have ranges. This is an example where we're actually positioning this object according to a normal distribution, like a Gaussian bell curve, and then using cross-entropy optimization to transform that distribution to try to concentrate it more on the cases where the system violates the property. So you can do more sophisticated stuff like that. Like if you don't want to start with a uniform distribution, you actually think it's more likely that there are counterexamples in some part of the space, you could put a prior distribution on the parameter, and then samplers which know how to deal with prior distributions. Actually, at the moment, I think it's just cross-entropy sampler and the Boltian bandit sampler will work with this kind of syntax. But anyway, the point is just that this is covered in more detail under the rubric of external parameters. So if you search for that in the documentation, you'll find this page. So let's see, how are we doing on the schedule time here? Right. So I guess would people like a little more time to keep working on this kind of thing, or is everyone happy? If people are happy, we could go to the break.